Tech giants are currently locked in a $700 billion spending spree to build out the global AI infrastructure. NVIDIA sits at the center of that build-out, with a valuation of $4.79 trillion and a stranglehold on 80 fabless designers like NVIDIA and Apple abandoned manufacturing to focus entirely on specialized chip architectures like GPUs. Meanwhile, foundries like TSMC abandoned chip design altogether. They focused their billions purely on the physical manufacturing process. Intel clung to the IDM model. While they balanced both priorities, they missed critical technology node resets, losing the manufacturing lead to TSMC and the architectural edge to NVIDIA. Mastering a legacy business model becomes a liability when the physical structure of the entire industry shifts around you. Today, any company trying to compete with NVIDIA faces two massive barriers. The first is software. NVIDIA spent 20 years building CUDA, an ecosystem now used by 4 million developers. Even when competitors like AMD build chips that beat NVIDIA's hardware on paper, CTOs often refuse to pay the engineering costs required to rewrite their entire software pipeline. The second barrier is physical. AI accelerators require massive chip real estate, and TSMC's advanced 2-nanometer fabrication capacity is effectively sold out through 2026. Competitors are trapped between an entrenched software monopoly and a global manufacturing chokehold. Breaking that bottleneck is the core of Intel's 2026 reset, led by CEO Lip-Bu Tan. The first pillar is Intel Foundry. By opening their manufacturing doors to external designers, Intel is attempting to directly challenge TSMC's monopoly on high-end production. To attract those clients, they needed a physical technology lead. They call it the 18A manufacturing node. The innovation in 18A is backside power delivery. Instead of crowding power and data on top, Intel routes power interconnects to the bottom, freeing the top for signal routing. This separation reduces voltage droop and solves thermal limits, allowing chips to run efficiently without overheating. The second pillar is symbiosis. Intel Xeon 6 processors are now used as host CPUs inside NVIDIA's own DGX Rubin AI systems, making Intel a necessary partner to the industry leader. Survival hinges on this shift in ego. Intel is moving from trying to defeat the AI wave to becoming the physical infrastructure supporting it. This pivot is beginning to show in the numbers. In Q1 2026, Intel reported $13.6 billion in total revenue, supported by a 16% jump in the foundry division. Much of this momentum is driven by geopolitical demand. The U.S. CHIPS Act is injecting billions into domestic fabs to forcibly onshore the semiconductor supply chain. As Intel rapidly scales their factory network, they are positioning themselves as the primary alternative for companies needing reliable domestic manufacturing. Hyperscalers like Google and Amazon are building custom chips to reduce their dependence on NVIDIA. For those companies, Intel's shift from a competitor to a neutral manufacturer provides a critical release valve. In a severely constrained manufacturing market, Intel doesn't have to dethrone NVIDIA. It only has to become the foundry the world is desperate for.